services. So ability to, so if this is all Hi, this is George Crump, lead analyst with Storage Switzerland. This is another in our ongoing series of Chalk Talk videos on various technologies impacting the storage industry. Today what we're going to do is extend a previous conversation that we had about the Storage Hypervisor. That was one where we talked about letting the hypervisor control more and more of the storage and provide more and more storage services. So let's kind of dig in. What we're going to talk about today is adding solid state storage to the Storage Hypervisor to help with performance issues. So let's kind of recap. What's the virtualized storage problem? Why do we even want to think about using solid state storage in this case? Well, the big challenge is as we change to a virtualized environment, the way storage is accessed changes a little bit from an initiation standpoint. In the old days, if you will, before solid state storage, we had a single server, and that server had a single application, and so one stream of data, if you will, is being accessed at a time. In the virtualized server environment, we change that entirely, and we load multiple applications of different types onto a single server. And so then each of these applications, of course, are going to be requesting data from the storage system at different times. And so as a result, the environment becomes extremely random. So we could have multiple accesses coming from this server, multiple accesses coming from this server, and so on down the line. And the problem with that is now all of that hits the storage system in a very random nature. And so as a result, more and more data is being accessed in a completely random format from a bunch of different applications. And what very quickly happens is the storage system itself gets overwhelmed and can't respond quickly enough to user requests. So what happens is we call this the I/O blender, where multiple applications on multiple servers are all accessing storage simultaneously. They kind of get blended up, if you will, and are getting bottlenecked by the storage controller, because we only have essentially one storage system typically down here to respond, or a finite number. So let's talk about how vendors have tried to solve this problem. Well, the good news in this environment is we do have a lot of requests inbound. So in theory, just as in a database where we added more and more disk drives to a storage system to get better performance, we could do the same thing here. The problem is that you would add so many disk drives that you would probably either fill up a data center or certainly exceed your budget. So the performance really becomes a problem. And then the other challenge is, even if we add a bunch of disks down here, the controllers that drive this storage system would also get overwhelmed, as would the network connections here. So we need to look for a different way to solve this problem, and vendors have quickly moved to solid state storage as a way to try to solve this problem. So we don't need to add an infinite amount of disks. Instead, we add just solid state to fix that problem. The challenge, though, is in a traditional storage system where we just add to the existing storage shelves solid state disk drives, we still have all the other things are the same. So we still have the same controller trying to manage things. We still have the same network I/O. We still have all those problems going on. So that really becomes the challenge in managing performance in these environments. So what happens then from trying to solve this problem is that all you can really do is add additional disks, add some solid state, and hope for the best. And what most people end up doing eventually is adding a whole nother storage system and sort of recreating the problem all over again. A plausible answer is to go directly to what we call a solid state storage appliance. And what that is a storage system that is based entirely on solid state storage. So there is no disk drives, and the system is designed to be able to provide maximum performance to that solid state technology. So it'll have better I/O connections, it'll have a better controller connection, and be able to get the full performance of solid state in that environment. The challenge, of course, is it's very expensive typically to buy just a solid state storage system, and quite frankly, not the entire environment doesn't need solid state storage. So what you end up with is the choice of making a very expensive investment to solve a problem that affects a small number of servers, or just living with average performance. And that's where we think the Storage Hypervisor really comes into play right here, is you can take that Storage Hypervisor and now mix these two different types of storage technologies. And here's how that works. So what if instead of buying one big and probably expensive solid-state storage system, we bought a small to medium-sized one, and instead of replacing, augmented our existing disk drive system. So this is disk, and this is a solid-state storage system. And then what we could do, very simply within most of the virtualization consoles, we can quickly detect which virtual machines are requiring the most storage I/O. Let's take those virtual machines and only load them on the solid state. So we'll put our hot VMs there, and then we'll just put all the other VMs over here. The value of the Storage Hypervisor is it can manage that movement back and forth for us. So as the technology changes and the VMs become more or less busy, we can transparently migrate virtual machine images from the hard disk system to the solid state system with relative ease. The advantage of doing that is incredible flexibility. We can keep this investment in the premium price storage relatively small and yet continue to expand here. The other advantage is we're putting all the performance sensitive virtual machines up on the solid state system. That clears this disk system out to provide better performance to sort of the mid-range and lower virtual machines. So in that balance, you also actually end up with better performance because this disk system is no longer throttled having to manage multiple high-performance virtual machines. So that's how that would work. So with this strategy in place, the solid-state storage system can augment the existing disk array, so you don't have to throw out your existing investment. You leverage the Storage Hypervisor to move data back and forth, and it gives you really the best of both worlds, a minimum investment in high-performance storage and a maximum benefit in capacity-efficient storage, giving you greater balance throughout your entire environment. I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in.